The population of fish in a lake can be expressed using the logistics equation. The derivative of P equals Kp times M minus P, where M is the maximum carrying capacity of the lake. Let's discuss the logistics equation first. dP over dt equals Kp times M minus P. So the logistics equation is just the growth equation, is this part, the growth, or the decay equation, but with M minus P, what we call the limiting factor. So what does the limiting factor do? Well, if you have like a minimum, for example, 0, and then the maximum is M, it starts off like an exponential growth. And then as it approaches the M, it slows down the population growth. It slows down. And if P is now M, if P equals M, dP over dt becomes 0, which means that there is no more growth. And subsequently, if we approach it from the other side, it first decays exponentially, and then as it approaches the maximum, it stabilizes the population. So that's what we're going to be doing here. So before we start anything, the question, we need to find a general solution for this differential equation. So let's put P prime here to simplify things, and let's distribute Kp to both sides in order to, in order for us to be able to solve this. So Kmp minus Kp squared. That's what's going on here. Let's put this on the other side. So P prime minus Kmp equals negative Kp squared. This is a uh, Bernoulli differential equation. So we usually solve this by dividing both sides by this p over 2 p squared here. So we get p to the negative 2 p prime minus km times p to the negative 1 equals negative k. We substitute this as v usually. So let's use v. And then derivative of both sides. Negative p to the negative 2 and then p prime equals v prime. So we replace this with negative v prime. Again, this is positive, so this is negative, so we just replace it with negative. Minus km, then v equals negative k. Let's multiply negative 1 to both sides to get rid of this coefficient. We get v prime plus kmv equals k. And then we need to find the mu, or the integrating factor, since this is t, since with respect to t. So e to the power km is the p of t here. So it's e to the kmt, that will be our integrating factor. So v prime times e to the kmt plus v times km e to the kmt equals k e to the kmt. On the left side, this is just a product rule thing. So v e to the kmt. If you know your product rules, you will get this. So that's good. On the right hand side, we just copy it. Integrate both sides with respect to t, of course. Derivative and integral cancel each other out, leaving us with v e to the kmt. Here, uh, the integral of this is e to the kmt times 1 over km, and k is already there. So we cancel k and 1 over k, so we get 1 over m, then e to the kmt. Then we add c. Now, uh, m is just a parameter, which means it is a constant. It's not an arbitrary constant, it is a constant. So we can multiply this by m, it still remains a constant, and that's what we're going to do, because I want to combine these into a singular fraction, like e to the kmt plus mc, which is going to be a constant, so we can denote it with c over m. Now isolate v. So v equals, on one hand we had 1, on the other hand we get ce to the negative kmt over m. V is p to the negative 1, which is 1 over p. So we flip both sides, finding the reciprocal, and we get m over 1 plus ce to negative k mt. And this is the logistics equation if we want the population and not the population change. So that's going to be our general solution. Next, suppose the maximum carrying capacity of the fish in the lake is 100,000. When 150,000 fish were dumped into the lake, it was observed that after a month, the population had lowered to 120,000 due to overcrowding. How many fish remain after 3 months, assuming logistic growth still holds? At this point, it's not logistic growth anymore, it's logistic decay, since it's going down, the population is going down. So, let's write the parameters. P of 0, or the initial parameter, is 150,000. P of after 1 month, it became 120,000 due to overcrowding. P of 3 months, what is the population then? Okay. We will use two methods here. The first method is going to be doing the calculus. Let's rewrite everything we know. dp over dt is given. Kp times m minus p. Also, P equals m over 1 plus ce to the negative k and t. Okay, just like with logistic growth, we need to solve for c and for k. M is already a known parameter, it's 100,000. I just put m because 100,000 is too long to write now. So let's do this. P of 0, we want that. On one hand, 150,000. On the other hand, we can substitute t for 0, so m is 100,000. Let's just put it now. Uh, Let me wrote 1,000, so 100 times 10 to the 3. Putting k here, it would confuse with this k. I don't want that. So 1 plus c times e to the 0. That's going to be 1, so we can just erase that. And we need to solve for c in this case. My method usually is to swap this c together because, so 1 plus c equals 100 times 10 to the 3 over, this is 150 also times 10 to the 3. The k is confusing, I know. So to remove the 1 there, we need to subtract this by 1. And it turns out this is negative 1 over 3. You can use the method of the calculator in order to solve that, but uh, solving it by isolating the C or the K is usually easier, and because the calculator is very slow at this kind of thing. So yeah, C equals negative 1/3. Now that C is there, we need to find K next. So again, P equals M. Let's just put M now. 100 times 10 to the 3 over uh 1 plus I should say minus 1/3 e to the negative k, and then 100,000 is this, and that's the m times the t. What we're trying to find is p of, let's replace this with p of 1. We know on one hand this is 120,000, and on the other hand we can replace t with 1 month. Okay, important that we write the unit here, so 1 month. Okay, now let's try solving for k. If you input this in the calculator, it will take you an ungodly amount of time, or the calculator would break. So here's how we isolate k. All right. So we swap them. So 1 minus 1/3 e to the negative uh, k times 100,000 times 10 to the 3 times 1 month equal 100 times 10 to the 3 over 120 times 10 to the 3. Subtract 1 on both sides in order to remove that. Multiply by negative 3 on both sides in order to remove that. So 3, like that. Take the natural logarithm of both sides in order to remove that. And then divide both sides by 100 times 10 to 3 times 1 month. So 1 over 100 times 10 to the 3. Then the unit should be inverse month. Okay. And that removes this, that, and for the final touch, we just transfer the negative. There you go. And you get K. Let me see. K is a natural, this is small number, 6.93 times 10 to the negative 6. Store this on your calculator if you can, because this will be important later on. And now, for our final P of T. 100 times 10 to the 3 over 1 minus 1/3 e to the negative 6.93 times 10 to the negative 6 times 100 times 10 to the 3 t in months. Now we need p of 3. And if you input this in calculator, you should get 104,347.83. And if you want to be accurate, since the population of fish is discrete, we can round this off. We get 104,348 fishes. Or if you're an engineer, you can say it's 104.35 kilo fish. Yes. So that's going to be your answer. This is the calculus solutions, and I will now show you the second one, which is using the calculator. So normally, uh, going to the calculator, let's go to the calculator for now. Sorry. Mode mode, and then we go 3. Where's the bottom? 3, and then look at that. We want the exponent here. Where's that? Yeah. So we have the x and the y column. The exp function is usually used in exponential growth and decay. So how is it going to work here? Remember the formula for exponential growth. So the formula for the population is m over 1 plus ce to the negative kmt. For exponential growth, let's put it in another corner. It's just ce to the negative kt. And that's the input. This is the input in the y column. If you see in this calculator, sorry, there is a y column in there. That's usually the input of the population. So you put the population in there. However, it only works for ce to the negative kt. This is a different thing. This is m over 1 plus ce to the kt. So what do we do? Actually, what we do is to just put the population in. No, hold on. So no, no. This is the population. This is the maximum, right? So what we do instead is to say this is like f. So we get p equals m over 1 plus f. Let's try isolating f. So we get m over p equals 1 plus f, and f becomes m over p minus 1. F is ce to the negative kt, which is exactly this, right? So we need to input m over p minus 1 in the y column in order to get the results that we are trying to find. So I'm going to show you through this one note. So in x and in y. So I'm going to input the time we do have, which is 0 at initial conditions and 1 month. And then I'm going to input m, 100k over 120k. Sorry, 150k minus 1. And for the second one, we have to input 100k over 150k minus 1. Now, this will turn out negative, and the calculator will just input math error because I don't know if it's lazy or whatever, but it cannot compute for something like negative numbers. So what we have to do is to take the absolute value of both, or just, make it negative so that make sure it's positive. I'm going to input both of them. So hold on. Um, divide- I made a mistake in there. That should be 120. This there. And look at here. Okay. If you calculated it without the absolute value, you would get negative numbers and you would fail. I know that because I did a demo run of this earlier. By demo run, I mean another take that took me like 30 minutes. So I wasted 30 minutes for that. So, and now, next step is you clear everything. So CA, press the CA button, and then remember the formula again. The input that we are going to find is F, and we need to find the population, so we need to do this. So in order to find the population, we need M over 1 plus F. F is the output. To get the output, we need 3y hat. In this Canon calculator, it is in the apps button. I will show you. Hold on. In the first you need to clear everything, so CA, nice. And then apps, and then regression, which is 8. And then look at the Y hat, the funky looking Y. There's a hat. It's very hot in there, I guess. So if you press it, you will get the Y hat button. If I put 3 Y hat, which is what we want, you will get 0.041. That's not the answer, of course, because the population is more than 100,000 at that point. So we need to input it in something like this. But since this is decay and we did an absolute value here, this plus cannot be a plus. Normally it would be plus if it's logistic growth. But since this is logistic decay, we need a minus in here. Okay, this is logistic decay. If this was logistic growth, okay, I hope you can read that. This would be m over 1 plus time t times y hat. Unfortunately, we need to do minus because it's logistic decay. M is 100,000. Divide by minus 3. Okay, so now I will show you my calculator. Ta-da! No, don't pay no attention. I haven't updated the calculator, so still it shows the result before. And if we click it, it should read. What should we expect? Hold on. 140, 104,348, or again, 104.35 kilofishes. So here, and there you go. That's the answer. 104,347.82, or just 104,348. Or again, 104.35 kilofishes. That's a joke if you haven't got it, by the way. So don't actually do kilofishes in your final answer. Your teacher will be mad at you. Okay, next part. After scientists dumped 1,000 fish into the lake, very rude, during the start of January 2023, 2,000 fish were counted a month later. Supposing they only count the number of fish once a month at the start of each month, what month and year would they find the population of the lake equal or exceed 90% capacity? Sorry. So let's write the parameters. At the initial P of 0, there are 1,000 fish. A month later, 1 month, there are 2,000 fish. Remember the timeline. This is January 2023. This is February 2023. They check the amount of fish after each month. Now, let's not go into the to the weird, calculator stuff like how February has 28 days and now blah 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 blah. We're assuming here that every month is equal sized. So just assume it's like 28 days per month, and then there's like a 13th month or whatever. No, 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 let's not assume that. Let's just assume everything as equal days. to make our job easier. So we need P of T and we need T for which this is 90% capacity or 90% of M. This is 90,000. What month and year would they find the population of the fish equal or exceed 90% capacity? So that's what we're trying to. First, we need to find time T. How do we find that? Well, again, we have two methods. I will show you first the calculus method, and I will show you later the calculator method, how we can use our calculator to solve this one. And it starts like before. Again, P equals M over 1 plus CE to the negative KMT. Okay. P of 0 is 1000, and it can also be written as 100K or 100. Okay, that will be confusing. Times 10 to the 3 over 1 plus c e to the 0. C e to the 0 is c, so we just can remove e to the 0. And by doing some calculator stuff and whatnot, c is 99. Next, now that we know c, we need to know k. So p of 1 equals 100 times 10 to the 3 over 1 plus 99 e to the negative k, which is what we're trying to find, times 100 times 10 to the 3 times 1 month. Okay, now I'm not going to do the complicated calculator thing, but just know k is 7.03 times 10 to the negative 6 inverse month. The unit is important. Or maybe not, but just know that we need the month in the in t later. So there we go. So we now need the t for which the population is 90,000. Uh, so 100,000 over 1 plus 99 e to the negative 7.03 times 10 to the negative 6 inverse months times 100,000 times t. And we need t. Now, I'm also going to skip the calculator stuff for this one. It might take a while on the calculator, and you should do it on paper first. But t is indeed equal, what is that? 9.66 months. So, let's count. So, on January is month 0. Month 1 is, 1 month after is February. March, April, May, June, July, August, September, October. During October, it's 9 months. But the event where the population of the fish exceeds the 90% of the capacity is in the middle of October, and they won't be able to record it, so they will record that it exceeded 90% in November. So the answer is November 2023. So that's the answer. This is more the numerical answer, and this is the answer that we're looking for. But let's try the calculator this time. So same regiment, x, y, and then the time of interest, 0 and 1. And then the populations of interest. So m over p minus 1. M is 100,000 over 1,000 minus 1. This is not the k from earlier. This is just 1,000. Okay? So number 1 is 100,000 over 2,000 minus 1. Let me input that on my calculator and I'll show you. Okay, 0, 1, uh, okay. Look in the calculator. Yeah, there we go. So that's the processed version of it. It's 99 and 49. So that is not the actual population. To find the time or time t, we need this m over p minus 1 and then x hat. And that in that way we can find time. Okay. So uh our m is 100,000 Our intended P is 90,000. That's the 90% of the maximum minus 1. And then X hat. I will input this one. Uh, Hold on. I'm inputting a lot of numbers here. Okay. 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 I will now show you how it looks like. This is what it looks like. 100,000 divided by, that's a fraction symbol, by the way. Fraction 90,000 minus 1, and then X hat. So what we're saying here is we need X if the other value, or the Y hat, is 100 E3, then my over 90 E3 minus 1. We should find 9.65 or somewhere adjacent, and there we go. 9.6578 rounded off, we get 9.66, which is exactly what we did find earlier. So this results in 9.66 months. So again, this is still November 2023. So I hope that was useful to you in your upcoming exams, and I'll see you in the next video. So stay zesty, Sandra heads. Bye bye.